We're going to do our recurrent layers today with Pytorch. I'm pretty excited about this because this gets us into LSTMs. Remember a long time ago when long-term, short-term memory was the state of the art? Do you remember that? Oh, I remember that. Oh, and then the gated recurrent unit. That was even more fancy, right? They're like, we need it more fancy than that. And then after, we're going to do the LSTMs, long, short-term memory. It's the precursor to the transformer. It's right before of it. We're doing recurrent layers today. I'm really excited about this because this was, or remember the RNNs? The RNNs, right? Used for sequential data is what we're doing. Okay, yes, yes, nice. That's excellent. It's my name. All right, we got it. Abdursul. Anything from this time series measurements from a scientific instrument to a natural language, like in a sentence, or DNA, nucleotides, DNA nucleotides, all right. And RNN does this by maintaining a hidden state that acts sort of like memory for what it has seen in the sequence so far. Show you what it looks like to use one though in action, LSTM based on part of speech tagger. So we're gonna create a classifier. I think that's what we're gonna do. A type of classifier that tells you if a word is a noun, verb, or etc. So that is actually kind of tricky. There is going to be an embedding. I looked through this ahead of time, so it's going to be a word embedding here. So we're going to need that, and it's going to give us a whole bunch of features of the sentence and language and things like that. Wow, yeah, wow. This is pretty exciting. So can it reorder? Can it reorder? I think it's order. I think it requires it to be in the right order. I think you would need, if you're going to test out of order, you need to switch the words around and use that as your training set when you're training the model. I think so. I think that's what it is. So if you want it to have orderless, you have to do it to, hey, see if we can make our LSTM work, even though the tutorial doesn't finish itself and it just ends right there, right? It's like, here's the code. We're not going to use it though. We're not going to use it. We're going to try to use it. We're going to try to use it. Because we understand enough of Pytorch now that we should be able to make it work, right? We should be able to make this work. So let's see if we can make it work. Embedding dimensions. Hidden dimensions. This one can be whatever. This one can be whatever, I think. Yeah, we just need it to be consistent. Thank you for the hundreds. Thank you for the hundreds, guys. Appreciate it. Vocab size is going, so we need this for our embedding model, which it turns out, I don't know what this is right here. What is this? I've never ever used this right here. Is this like a generic embedding model? How does this work? How are we training it? Are we, is it pre-trained? Embedding dimensions, I don't know, 10? We'll do 10 here. We'll just do 10 for everything. Target size, this is number of classes, right? Target size of classes, double check. It is, it's number of classes, so we'll say classes. Classes, there we go. Number of classes right there. Okay, so we're gonna create an embedding model. So self.embedding equals torch.nn.embedding. Just like that. Oh, we've never done this before. All right, self.vocab size, comma, and self.embedding dimensions. There we go. All right, so now we've got our embedding layer, which it describes as nothing. There's no words around it. Okay, now we need our LSTM, self.LSTM, our long short-term memory, torch.nn.LSTM, like that. No, yes. And then we're gonna do our embedding, self.embedding. You recently been really into the Frutiger? Oh, our long short-term memory self.embedding, embedding dimensions, comma, we need the hidden dimensions, right? Probably, I'm guessing, I forgot already. Yeah, it is hidden dimensions, perfect. I assumed, now we're gonna do one linear layer, L1 equals torch.nn.linear, and that's going to be our, is it gonna be hidden dimensions? It is. Oh, that makes it so much easier than ConvNet, doesn't it? Oh, because then we don't have to translate and we don't have to reshape the view after it comes out of ConvNet. It's just right there and good to go. Over here. All right, so let's do that. Def forward, self, inputs, and then we're going to get our data. Are you making an app? We are building a long, short-term recurrent neural network. a toy version of it. We've remember these from the past? I don't know if you remember them from the past. Because Transformers took over and we forgot about LSTMs. They're gone now. Nobody cares about them anymore now that we have Transformers. And so I figured, why not? Let's take a look at it. Let's go have some fun with some Transformers. Or before Transformers came out, let's have some fun with the old legacy stuff. Which, there could still be some, real world applications with this for classification, especially when you're doing time series data and you need to have a context about a bunch of different repeating patterns in a row, right? So LSTM, pretty good for that. I think LSTM is pretty good for that. All right, so we're going to do out equals self.embedding, embedding, then we're going to say inputs. I think. Is that what we can do? Can we do that? Is this work? Do we need to vectorize it first? What are the inputs? Let's find out here. Word and okay. So sentence out, right? That's all we needed. I'm just shocked. I'm shocked. All right. So we get an LSTM out. What's going on here? Self.LSTM embeds. What's this? What's this right here, you guys? This won't work. This is broken. The tutorial's broken. Right here, you guys. What is that? What is this right here? This won't work. We're gonna get an error. If we type this out, it's not gonna work. Embeds.view. Oh, I'm wrong. You're like, no. Look at the next line above it. That's called embed. I'm like, what is it? Because I called it out. All right, fine. I'm going to call it E. I'm just going to call it E. You're supposed to say, Steven, no, you're wrong. I named it wrong. Or so this will be L. So EL. Okay, so this will be LSTM embeds view length of the sentence 1 -1. All right. So I don't know what this is going to do. So I'm going to print that out. That's what I'm going to do. I'm going to print that out. So let's do print E. And let's see what that looks like. What does the input need to be like? Creating a long short-term memory, a recurrent neural network, and we're going to make it work. We're going to try to make it work. Oh, it's not a tensor. Does it want it to be a tensor? Okay, we'll make it a tensor. So it lied to us. It gave us a model that can't auto-convert it. Then what's the embedding for? We're gonna have to look this up, you guys. We're gonna have to search some things. Some layer. Constructor has 4 arguments. Vocab size, the number of words in the input vocabulary. Each word is a 1-hot vector. Oh, in the vocab size dimension space. Okay. This changes things a little bit. Vocab size is the number of words in the input vocabulary. Oh, well, wouldn't that be okay? Vocab size, embedding dimensions. Okay. So this will be the 1-hot size. All right. So on input, would we need... Because over here, wait. There's an example right here. It's showing something different. Input indices is showing the word indexes. Right? Batch, sequence, length, embedding. Okay. We need to vectorize it, or we'll say our vec is... And then we need to do a... sentence. We've got our words, so we need to create a vector here. And it's got to be a batch, and then we need to turn it into a tensor. Torch.tensor, like that. Then we need to say I for in words. And then we need to return. No, this is gonna be W. This was the W. We need to return the based on the dictionary, self.dictionary, and we're gonna look this up. There we go. Okay, we return the vec. Okay, that should do the trick. So let's do sentence equals vec model dot lookup, and we're print our vec, and we also want to print our sentence. Okay. And we're gonna hide this because we don't want to do that right now. Okay. Now, let's see if we vectorized our data. Oh, come on. Okay, wait. Words isn't, okay, one second. This is an I. No, that is the word. So that is a word. Words are right here. Words, right here. Oh, got keys. So we don't need to do that. So this is going to be the word, but we needed to enumerate it because we need LSTM out. Now we do the actual LSTM part of the picture. Okay, so our output out equals. Do we need anything else? So we got our embeds here. Do we need embeds again? No. Do we need LSTM out? Just once. Okay. And then the scores doesn't matter. Tag space. Okay. So let's do the LSTM first here. Okay. self.lstm. All the libraries rely on one another while writing code. How these libraries work together? Well, let's see. For the most part, there we go. Vectors. Yeah. All right. Look. Oh, no. That's wrong. All right. That's wrong. Wrong. Okay. This needs to be here. Like this. Like that. There we go. See, this is why we debug. Much better. All right. Now it's the right shape. Now we just need to make sure that everything on the input side is doing the same thing. Okay. Magic, right? It's magic. It's because right now we're only using one library called Torch. And here's the neat thing about Torch. It acts the same way as NumPy. It's pretty cool. It's pretty neat. All those fun math things you can do with your classes and your arrays and things like that, you can do that with Torch. And it can run on your GPU, which is a lot nicer, I think. Although NumPy, I'll still use NumPy day and night. I'll still use NumPy. Okay, you guys. Let's see here. Okay. Get rid of that. So we got our embedding on the out. We're returning our vectors properly. And then we need to do out 0, like that. So here we go. I think that looks good. Okay. Did we do it? 1, 1, 1, 1, 1. Yes, we did it. Okay. So we have our output and we have our input. So we defined our full model. So that part's done. The LSTM takes word embeddings such as inputs and outputs hidden states with dimensionality in the hidden dimension. So we're almost done with this here. Def forward. So let's do tag space, which are classes, right? Self dot hidden. So I call it L1. I think I called it L1 on my side. L1, yeah, because it's linear. And then we're gonna go out. Do we activate it? Oh, we gotta split the view. We're gonna do the view again on this. LSTM out.view, which is definitely gonna work, right? With the softmax? Did we do? Oh, we did. Okay, yeah. All right, so log softmax. So we need to do functional, right? So from torch import, or do we say import? Whoa, Kyle! Thank you for sending the 5 gifted memberships. Hey, thank you for the hearts, you guys. Appreciate it. Is it gonna work? Did we get it working? Here we go. We're gonna find out. No! Oh, it's because we didn't. All right. Wait, little tiny errors. We're gonna make this work. Okay. W. Run. No. Run. Yeah, there, we did it. With 10 outputs right there. Although it's size of 4, which is weird, so it's not really the right, but it doesn't crash. So we're gonna take that as a win. It's not the right output. Is it though? Is it? No, this is incorrect. It's not correct. It's supposed to be 1. It's supposed to be 1 vector. It's supposed to be 1 vector, and it gave me 4 vectors. So we got some work to do. We do have some work to do. However,